Okay, well, welcome back. And what we're going to do is we're going to go to section 13.1, or for those that aren't following along at home, this would just be introduction to the law of sines. The law of sines will be, we're going to be solving oblique triangles in these next two sections. And if you want to know what an oblique triangle is, well, let me show you. And this, we have that right there. Oblique triangles. Oblique triangles are ones that do not have right angles. In trigonometry, normally we use all triangles with right triangles, and that's where the unit circles come from. Well, now we're going into oblique triangles. Oblique triangles. And so a standard notation, the angles of a triangle are labeled as A, B, and C. So those are the angles. And the sides are lowercase letters of A, B, and C. A is opposite of A, B is opposite of B, and C is opposite of C. Now, to solve an oblique triangle, that means you need to find all three measurements of at least one side and the other two parts of the triangle. Either two sides, two angles, or one side and one angle, and so on and so forth. This also goes back to our geometry days, which I love, all right, in that we are going to be finding essentially congruent triangles, okay? And so we're going to be comparing two different congruent triangles that are oblique, and we're going to use these, which are known as AAS or ASA, or the naughty triangles, where two sides and an angle opposite them, where it's the SSA. And so, with that, we are going to be looking at these because all of these triangles right here, okay, are going to be used with what's known as the law of sines. And so if we have a triangle with an angle, and a side, and an angle, side, or angle, law of sines. If we have a side angle, that's a special triangle. We're going to be looking at that in the next video, but that's what we have there. Just for a little bit of preview, if you have side, three sides, and if we have a side, two sides, and an angle between them, we are then going to be using what's known as the law of cosines, and that's going to be our next section in the next group of videos. So, what is the law of sines? All right, so take out your notes. You can write this down. This is the law of sines right here, my friends. Okay. If you have a triangle A, B, and C, okay, so A opposite A, B opposite B, and C opposite C, acute or obtuse, we know that given this, we can create, find the altitude or the height of the triangle by using a sine. Now, how do we do that? Well, if right here we have A. So if I have A, the sine of angle A is going to equal opposite H, all right, over, okay, if we see this right here, hypotenuse in this case is going to be B. Okay, if we look at that one. Solving for H, we have B times sine of A. B equals sine of A. Now, let's go over this right here, and that's going to equal H. Well, H in this case, let's now compare it to, let's say, this angle B. So if I said angle B, the sine of B is going to be H over the hypotenuse. In this case, this is the hypotenuse, because remember, hypotenuse is always opposite the angle. All right, and it's going to be A. So now we have sine of B times A equals H. Well, since in this particular problem, and you can do it for either one of these cases, what we have is we see that H are equal, and we can write it as B sine of A equals A sine of B. In solving this, well, we can actually do a little proportion magic in saying that we see that the sine of A, divide both sides by A, is actually going to be divided by A. And the sine of angle B, and divide by the other side by B, is this right here, which we can see is the same, but simply the reciprocal of this ratio of these two proportions. We could then, if we wanted to, readjust this and then create another one, rotate this around, and I'm not going to go through this, but if you rotate it around, and let's say we changed H going this way, okay, do the same kind of deal, all right, what we'll have is sine of C, all right, is going to be H over A, and then we would have A sine of A, which we realize is H, and we would go through the same process, and we realize that this ratio would also equal the sine of A over A, and which is equal to the sine of B over B, and so we essentially proved the law of sines. This can also be done with an obtuse triangle and all the other ones. Okay, so that's where it comes from. And normally I use the law of sines like this, the reciprocal. The sine of an angle over A equals the sine of the angle over its opposite side B, and that equals the sine of C over C. All right, so this is what the law of sines are. That is the equation. This is what we're going to be using. In the next videos, we're going to now go through and solve them and use it to solve a right triangle, or sorry, an oblique triangle. All right, so you can look forward to the next videos.